Hey PCWorld fans, I'm here at Intel's Performance Marketing Lab with Hannah. Hannah, please tell the fine folks at home what you do here in your title.
Alrighty, so I am a development tools and software engineering manager. My job is to make sure that we not only collect data, we collect it correctly, we do it accurately, we do it efficiently, and we do it automated where we can. So anything you see in the news or on billboards, it's my job to make sure that the right people collect it and that it's actually representative of our products and how people use them.
Awesome. Well, we've already had a ton of good conversations.
Yes, we have.
I was through the course of those conversations, I was like, I think a lot of people need to know at home what it is that Intel does with whatever CPUs that come out and how they're tested, why they're tested, all that kind of stuff. So let's dig into it. I'm going to ask my first question. I'm going to actually answer it first.
Oh,
so
okay.
real quick. The first question is, what is the goal of your team at the Performance Marketing Lab? My answer, which would be the internet, is to say to make Intel CPU look the best on bar charts. Is that true?
So I can understand why you would think that. But at the end of the day, I want to make sure that the products that our chips are in are useful, function as expected, and that people actually care to use them. So can I use a food analogy?
Please.
Okay. When you think of a computer, it's a meal. And it can be beautiful, it can be stunning, but there's so much that goes into making that. And if I gave you a pile of ingredients, you wouldn't make the same dish. If I gave you just a recipe, you wouldn't make the same dish. If you go to a restaurant and sit down, there's context and nuance and so much there that goes into that experience. Now, when I think about it, I'm generating a core component of this meal. It's going to be the chicken in your dish. And if I give you something bad, you're not going to want to eat it, and it's going to leave a bad taste in your mouth. But at the same time, getting a consistent dish requires a lot of effort. And that is fundamentally what we do, is that when you see a single score on a screen or in an advertisement, that is just like one little image of a greater system that goes into generating that. We don't do it once, we do it over and over again. We try to ensure accuracy, consistency, reliability. What I make, I want to be representative of what your expectations are. And at the end of the day, I don't want to give you a bad experience or a bad meal. I want you to enjoy it and come back again.
Okay. Well, as reviewers, it's our job to take whatever product and give an expectation of how it's going to perform.
Of course.
And a lot of people see that as unbiased, right? We're the middleman. And a lot of people would see, okay, well, if you're benchmarking the CPU, once again, you want it to look good against the competition.
So
why
it to look accurate?
Yeah. Okay. Yeah, we'll get into the accuracy for sure. So then it's like, okay, what do you feel like your team's goal is then, when you're getting in a CPU or whatever to test?
So despite being a performance marketing lab, I'm not making marketing materials. What I'm trying to do is tell a story about a product.
Okay.
I want to talk about what's different about it. I want to talk about what's new, what's innovative, how it's changed. What is the new technology? What is it enabling that the previous one didn't do? And that's not always straightforward to communicate, especially when you're looking at standard synthetic benchmarks. They're telling you a moisture rating of the piece of chicken you're eating that doesn't necessarily correlate to a good meal. And so when I look at it, I want to look at it from a holistic perspective. And it's in my best interest to understand what makes it taste good and what makes it taste bad. And in order to do that, I need to trust that the measurement tools I'm using are consistent and that the data that I'm generating is consistent. What marketing chooses to take to tell the story, to make sure that we're communicating effectively what we want to about our product, is just one component of a major system. So is my good job to make a marketing claim? No, my job is to make really good data that actually communicates clearly what our product is and what it does.
Okay. Well, then, so how do you pick the data to test? You've shown me some of it. You actually They do a lot of
What
testing.
don't I test?
Yeah, exactly. So like then number one, how do you pick? And then number two, why do you leave some stuff off actually?
Relevancy. If I want to look at graphics, like you want to pick a benchmark that's actually going to measure what it is you think it's going to measure. And oftentimes I find that people will measure everything in the kitchen sink without understanding what it truly means. I believe that there's a purpose and a story in each measurement. So if you're going to collect a 3D Mark score, what is that actually telling you about the product? Are you using the right 3D Mark score? Do you understand what it tells you? Do you understand its sensitivities? Do you understand how the different hardware components manipulate that score? Like if you don't know what you're asking for, we're already starting off backwards. And so my goal is to, especially internally, but like, and this part of why I want to have this conversation is like, be on the same page about what that underlying data point means. So in general, yeah, let's collect a bunch of data, but the underlying meaning of that data to me is a little bit more important. And I want breadth, not just depth. So you want to say, okay, what is a measurement that it flexes each different part of the computer? Is it memory? Is it speed? Is it RAM? Is like, there's so much to it. Is it power? Is it the GPU? Is it the NPU? There's a whole bunch of different stories you can tell. And so for me, I'm looking at how do I tell a story about each component? And then how do I deep dive on the things that are going to be most relevant? So sweep off the stuff that's unnecessary, focus on the core fundamentals.
Okay. It's a lot of good theoretical stuff. I want to get into the nitty gritty of what you and your team does. So you have a product that's on the roadmap.
Yep.
You get it in. How early do you get something in to start testing it?
As early as I can.
Yeah.
Yeah.
Is there an average time frame that, like, say, a desktop CPU?
I try to get things 8 months before launch, typically. I want to get it early. I want to get it raw. I don't want like the newest BIOS or drivers because we're going to be doing iterative testing because oftentimes you find nuance as you go through. And so my goal is like, okay, let's build a ruler. Here's the baseline that I want to test. So every time there's a change, we'll get a gold config, say weekly. I want to test it. And then a new one comes out. I want to test it again because in theory, we're telling the story of the product. We're telling what architecture is looking at, how it's being tuned, how it's being changed, developing and growing it over time. And is it even performing as expected? Why not? Is it yield? Is it like, there's so many independent variables here. And so I want to know early on the state of a product so that we have time to go and fix issues as they arise. But then it also leads me kind of in the direction of where we think it's going to end up. And I mean, that alone is a really cool story. Like growth. Yeah. Who doesn't want to say that?
And how different is the performance at such an early stage? You're talking about 6 months before launch, like from that period when you first get something in to release. Like, are we talking about like, oh wow, like we've seen a 20% increase in performance just because tuning was still happening?
Sometimes that can be the case. I mean, you'll have 4 weeks of continual improvement, and then one test and you lose it. Software is a major piece of that. Like, how do you tune the frequency? How do you make sure that the right threads are being spawned and that they're being distributed properly? There's a lot to it.
Yeah.
Yeah, and so you do the best you can with the tools you have available, and you go in with, a good faith effort and tell the best story you can tell.
And so over the course of that time, you're testing and retesting,
Constantly.
and testing and retesting.
Oh, yeah.
How do you keep track of all that data?
Oh, spreadsheets are life, but there's databases. And one of the great parts about Intel is that we have experts in a bunch of different spaces all throughout the company. And so what data that might not mean much to me might mean something important to somebody else. And so typically I work with all of our partner organizations, and if they're like, oh, we think there's this bug, we think there's a regression, we think there's some optimization here that we can make, we collaborate together and they're like, this is what we want to test. We think that these are the benchmarks that will tell us this information, and we collaborate. And I'll do iterative testing, and sometimes it'll be high memory, low memory. There's so many variables we can play with, but There's other labs that can do it, but when it comes to more finalized products, that's where we get to do a lot of the tinkering, and that collaboration is incredible. I learn more every day about every single product because I have really smart people around to educate me.
Nice. Well, so take a single SKU of a desktop CPU, where I'm just going to use this as an example. Like, how many different ways are you testing it? Are you testing it different RAM timings from, per 1,000 mega transfers per second with, different PCIe slots populated? Like how many different ways are you testing?
There are definitely
something?
labs that do.
Oh, okay.
I tend to try and focus on much closer to the end products.
Oh, okay.
And so at that case, maybe I'll test 4 different types of memory, sometimes different memory manufacturers, maybe a few different GPUs. Tweaking BIOS settings is always really interesting and continue all kinds of stuff. I mean, the VBS on-off debate went on forever. And so when it comes to some of that, it's more of that fine-tuning and especially for gaming, how do we make sure that it's providing the right experience and meeting expectation? So yes, while in general Intel can test all of the above, I tend to focus much more on end product.
Okay. And then you obviously need to compare it to competitors.
Of course.
You're getting other competitor devices in. How are you testing those? Are you trying to find a way to do one-to-one? Are you trying to give them the best case scenario and then put it up against your best case scenario? How do you do that competitive analysis?
It doesn't do me any favors if I hold them back. At the end of the day, I look at competitors' websites and I say, how are they measuring it? How are they talking about their products? How are they setting them up for the best possible? Because if their results are representative of how they would recommend their product being used, I'm doing myself a disservice if I don't look at reality and actually try and do that. So if they want 6,700 megahertz of RAM, why wouldn't I give them 6,700 megahertz of RAM? The only person it hurts is myself. When we think of apples to apples, it doesn't necessarily mean that everything is exact. It means that we're creating a realistic and fair scenario to give everybody the best chance possible.
Okay. Yeah. And then, is there a rough time period where, say, a lot of the tweaking's been done, whether it's fixes or just kind of tweaking things, to then the actual release where you're like, oh, you know what? Usually a month out, things are where we expect them to be, and this is what we're going to go and tell people.
Yeah. So I'd say a month is fair. I mean, the more time, the better. We have, correct me if I'm wrong, so it's the PV. Yeah. So we have PV, and that is our what does it stand for? Product validation. Yeah. So it's our product validation. It is. So PVs, we think this product is ready to go. It's ready to ship. OEM partners have it. This is what we want to plan and ship. At that point, it's on. I will test everything. I will go super thorough. I want competition to have the best opportunity possible to, combat against our measurements. And that's where we truly get the story. And so much of it is, you go in with oh yeah, we're Intel, we want to be the best, but also what is reality? The data tells the story, not necessarily vice versa. So if we have a PV build, let's go for it and let's see what we can say.
So what happens if you have some sort of processor that isn't performing up to expectations?
What happens?
Right? So do you just try to find a different narrative, test a different way, or is there a way to, run it back and be like, hey, you know what, this is just not ready for launch? What does that process look like?
It's a little bit of both. I'm fortunate in that I don't actually have to write the copy. And so they have the opportunity to fix things. But at the same time, I'm a big believer in Kaizen, which is continual improvement. And so if we release a product and it's not quite there, but we'll have a driver release 2 weeks later that'll have it, honesty is the best policy. Things aren't always the way that you hope they'll be, but we're putting forth a good faith effort. We're doing the best to build the best quality product that we can. Hiccups happen, and you roll with the punches, and you do better next time.
Yeah, no, I mean there's been problems, and I would love to hear how how those things get addressed. On the other side of the fence, the Ryzen 9000 launch had some really big problems. We even tested it, and we're like, these numbers don't look right. There's a whole story around there, whatever. But like something like the Raptor Lake Gen, when it's like, oh wait, some of these are not working anymore. Like do you got to go back and then test? Like,
Oh, absolutely.
Was that not seen at all during the the whole testing beforehand? Like what happens internally?
Yeah, so at the time, my data didn't show the issue. And so we went forward with what we thought was completely valid data and was accurate, and we learned from it. And so then, we took a step back, and how do you triage the situation? Because at the end of the day, you want the customers to be happy. And so, a lot of effort was put into how to resolve that. And then with the next launch, we approached it differently, and it actually having those opportunities to change our methodology and to know what to look for and to catch certain pitfalls, like, it makes us better in the long run. It's unfortunate, but it's part of the industry.
Well, that's what's important, is to learn from it, right?
Yeah.
Mistakes happen, learn from it, move forward. Was there anything around the Arrow Lake H or S launch that it's like, hey, you know what, like we need to learn from this, that was a key takeaway, or no?
What I really like about it is it gave us the opportunity to step back and really think about our user space, which is, how is the average person using this product? And so testing the way they would from raw components off the shelf, putting them together and going through that experience was something I personally did. I ordered all the different parts, I sat down and I logged, how long did it take me to build the system? How long did it take to get all the software updates? What were like the roadblocks? What were the hiccups? And then finding every driver, like, please, it took forever. And what's great about it is that, you get so focused on one particular thing that you lose sight of others. And at the end of the day, I never want to ask my team to do anything that I'm not willing to do myself. And there's always room for improvement. And so I had a laundry list of things and recommendations that I would change. And so I turned around and gave it back to management, and we communicated. And I think you'll be surprised this next round. So there are changes afoot. I'm very optimistic that this will go a lot better.
Nice. A couple more questions we'll get out of here. One of them, the late Gordon Mong would always say, sometimes jokingly, that when a company puts out numbers, those numbers are vetted by lawyers, and there's always some lawyer in the background that says, we have to check these numbers before we put them out. Like,
oh, yeah.
How much do you have to deal with lawyers, and are they looking at all your numbers to make sure that?
They are like my best friends, but it's also because I am such a stickler. So absolutely, everything we have gets vetted by lawyers, as it should be, because we don't want to say something that's inaccurate, because that's not fair to customers, that's not fair to users. At the end of the day, we want to stand by the product we make. But the reason why they're my best friends is that I'm a stickler in how we measure. Every data point that's on a slide that's public can be tied back to a specific test plan, tied back to specific devices, tied back to specific instruction sets that are logged. You want to see a game point, I know which version of the game it was tested on, the day it was tested, who collected it, which instruction set was used, because at the end of the day, that's my job. And it's not one data point, it's many. Like, a single example of anything is not representative. I want it to be robust. I look at medians, I look at standard deviations, I'm getting power traces, I'm getting thermals. I want it to be accurate, and I don't want it to be putting a false load on the system and manipulating the underlying score. So the lawyers like me because I want it to be right. Whether I win or lose, that data will be correct.
And I could say I've seen some of the spreadsheets. It is very thorough. It has everything
are life.
documented.
Put that on my tombstone.
Yeah. Last question. If there was one thing you wish people knew about benchmarking, what would it be?
Oh man, one thing.
Or one thing that's important that you wish people knew?
That there's an art to it. It's not just a science. I mean, I've took a lot of calculus, software engineering, but like what I learned is that there's many ways to accomplish something, and you can still get to the end goal. And so part of what I want to, kind of collaborate with you on is how you test matters to me. And I want you to care and approve of how I'm testing. Because at the end of the day, like, we have the same goals, and there's an art to how we do it. It's not always necessarily a science. It isn't a click a button. It's not necessarily straightforward. But with that art comes collaboration. And at the end of the day, a Cinebench score will tell you one thing, but how somebody uses that device when they pick it up off the shelf is what fundamentally matters, I think, to both of us. And
Definitely.
I would like to help, make that happen.
Well, I appreciate that, and yeah, the more that you guys are able to be open about, how things are going on, the better. So I appreciate you sitting down and chat with me about it.
Please
So,
come visit more often. This was fun.
Yeah, thank you so much, and thanks everybody for watching. We'll catch you in the next one.